Hello everyone, welcome to Snippet Nugget, and in this video we are going to discuss a very basic question. It is about reversing this string. So let us just take So here the question statement is, if you are given a string, you need to reverse it in place. So what does it mean by in place? It means you have to reverse it in the same string variable. You should not use another string variable as temporarily holding it or maybe for printing it. You basically need to reverse the string in the input string itself. Okay. So what is the purpose of this question? It is basically asked to test the recursion logic. If in the question it is explicitly asked to reverse the string using recursion, then here the interviewer is basically testing the recursion logic of the candidate. Also, it is for testing the swapping logic of the candidate, whether the candidate is comfortable in thinking about how to swap two of the characters. Okay, so let us move toward the solution of this. There are two solutions to it. One is iterative approach, one is recursive approach. We will first look at the iterative approach. Let us say the string S is A, B, C, D, E. We need to take two pointers or two variables, we can say, for start and end, which will basically point to the start of the string and the end index of the string. Okay, so when we have to reverse the string in its own place or in place, here what we are trying to do is, if let us say our string is A, B, C, D and E, we are trying to basically swap first and last character and then second and second last character. Okay, and obviously the middle point. So the middle point, it will not be swapped. Okay, so we need to do this operation of swapping the first and last, second and second last, and third last, and so on till the midpoint. Okay, why till the midpoint? Because when you have arrived till the midpoint, it means that you have already swapped the whole string. If you will swap it till the end, it means you will again reaching for the same initial string. Okay, so please note we have to swap only till the midpoint. So we will run a while condition till the start is less than end, because at the point of the midpoint, start will start becoming greater than end or equal to end. So we will strictly check for start is less than end, and we will swap the start and end index. Also, once this is swapped, we will increment the start pointer or the index. Similarly, we will reduce the end index. Okay, so this is the iterative approach. What would be the time complexity for this? It would be O of n. Why? Because this while loop is running till the midpoint, so it is running basically n by 2 times, because it is the time complexity analysis. So we will ignore the denominator by 2. So the effective time complexity would be O of n. Okay, where n is the length of the string. Let us see the recursive approach for the same question. In this approach, what we will do is we will apply the same logic of swapping the first and last and second last and third last characters, but with the recursion. So in the recursive function, we will write our base case. Okay, we will write our base case as whenever the start is less than equal to end, we will return the whole string. Otherwise, we will keep swapping the first and last, second and second last, and so on. Okay, so we will swap the start and end, and again we will recursively call the same function with the same string as one of the parameter, and the start and end indexes incremented and decremented. So this is the same approach as iterative, just that we are using the recursive function. Okay. Now let's analyze the time complexity for this recursive approach. We will try to derive the time complexity using recursion tree in this case. Recursion tree is basically the representation of the flow of recursive function. So the first time the recursive function is dealing with the n size array. The second time the recursive function is dealing with n minus 2 size array, or the string we can say, because the start is incremented and the end is decremented. And similarly, the next n minus 4 and so on till the whole string is covered and we have reached the midpoint. So basically, a start has traveled n by 2 distance from the starting and end has traveled n by 2 distance from the starting. So if you will observe how many times, like what is the depth of this recursion tree? N by 2, right? Because it is traveling from n to 0 by taking steps of 2 at a time. So the depth of the tree, recursion tree, is n by 2. So what would be the time complexity? O of n by 2, or in a simplification or simplified version, we can write big O of n. This is the time complexity for this recursive approach. It is the same as the iterative approach. But one point I would like to mention here is, what would be the space complexity for the recursive approach? In this iterative approach, the space complexity would again be O of 1. Why? Because we might be using just a temporary character variable for holding the one character. So the space complexity would be constant, big O of 1, because we are not using any extra string or any character array or something like that. We are just using one single character for temporarily holding that character for swap. Okay, but in this case, in the recursive approach, even though we are not explicitly using another string for holding the reversed or any of this string, but during the recursion stack, what will happen is, first time when this recursion is called, we are passing a string variable. Second time, again, the string variable is passed to the recursion stack, and so on till n minus 2 times. So each of the time when the recursion function is called, the state of the functions are saved in this recursion stack. So n by 2 times the function's state will be saved here. Each time we will save the string variable ABCD in this recursion stack. So how many times we are basically saving? N by 2. And what would be the length of the string? N. So what would be the total time complexity for, space complexity for this recursive approach? Big O of n square. But please note, this is the space complexity or space taken by the programming. It is not taken by the user logic. It is taken by the programming logic. So it is implicit space complexity. Okay. So thank you for watching this video. If you like this video, please subscribe to the channel for being notified for the similar kind of videos. Thank you once again.